So module 4 talks about safety assessment. Just like with the previous modules, I'll have a couple of a couple of excerpts on Blackboard. And these include, for example, the two NASA documents you see here, which are very informative about how to do fault trees. And we'll talk in this set of slides a little bit more about that as well. So far we have talked about, we've actually give definitions for failures, risk, and we've talked about what safety means. We have also talked about the certification process, what activities are involved in the certification of a system. And a system in this case could be an aircraft, but it also could be a function, a avionics box on board of this aircraft. Then the most recent module, we talked about some systems engineering. We talked about what activities are involved in the life cycle of a system. And remember what I mean by life cycle of a system, I mean the phases it will go through during its useful life, during its life. So all the way from design to disposal. Well, what we're going to talk about in this particular module, we're going to talk about what we call the system safety assessment. And if you go to the Aerospace Practice ARP 4761, the definition for the system safety assessment is that it's a systematic, comprehensive evaluation of the implemented system to show that the relevant safety requirements are met. I want to add to this that part of the system safety assessment process is really also to derive these safety requirements and then of course evaluate if they're met. Now if you look at this block diagram that we also showed at the end of the systems engineering module, we saw that in the systems engineering model we talked about kind of mostly the system development life cycles and processes, which are specified in 4754. And actually that has been updated. There's a version now called ARP 4754A. And that's put in context, of course, in hardware-specific life cycle and a software development life cycle. So this is DO254 and there's 178B, and also for 178B there's an update 178C for that. But what we're going to focus in this module is the safety assessment processes, ARP 4761. So let's look at, this class will be really focusing a lot on safety critical applications, and a lot of the examples there are associated with aircraft because within Ohio University we have a lot of expertise in this area. So we saw a couple of things. We saw in module 1 that if you look at safety, we determined that safety is really defined with respect to not just human life but also property in the environment. So if you have an aircraft crash and everybody would survive the aircraft crash, but you would lose the aircraft itself, that means what is referred to as loss as property. The aircraft is lost. There is a significant economical, but also means you lost the hull of the aircraft. So it means safety is impacted. Yeah. So the second element that we talked in that module, we talked about failure, and we defined failure really as an inability of a system or component or device to perform its intended function for a specific time under specific environmental conditions. In other words, it kind of is somehow related to reliability. And then if you take these two items and you define them by aircraft, there is actually a set of rules in the Federal Aviation Regulations, section 25.1309 and section 23.1309, that talks about all the equipment, systems, and installations on board of an aircraft. So, and in that particular paragraph, it talks specifically about the safety aspects. Now, since it's a very short description, if you go to 25.1309, you can actually find it on the web pretty easily. You can actually see that they talk about equipment system installation. Well, to give a little bit more insight in that, the FAA has also released advisory circulars related to it. Advisory circular 25.1309 to give you additional information or guidance on this particular rule. Now remember, 25.1309 was with respect to transport category aircraft. 23 is normal aerobatic and and small commuter category aircraft. But in these two advisory circulars, they talk about, what to do about the systems and equipment that you install on board of an aircraft. And it expresses this in terms of failure. So what it does, and we've talked about this before as well, it establishes a failure condition classification for a particular function. It says it's gonna identify, and this is part of the safety assessment process really, for each system or device on board of the aircraft, what kind of failure condition classification it falls into. And of course, remember this from our first set of notes, it depends of course on the severity of it. Yeah? And the severity is expressed in terms again of people and property. Now, the one thing that you have to remember from that is that if you have a very severe consequence associated with the failure of your system, you have to make sure that in your design you're going to make sure that it's extremely improbable that that failure does occur. As if there is no effect really whatsoever, in your design you can allow for the fact that this failure occurs more often, it's more probable. Yeah? Now, one thing I have not talked about in section A is this stuff on the bottom. These are development assurance levels as specified in D0178C and B that actually are what kind of software you would need. So if you have a software component and the failure of the software component would lead to a catastrophic failure, then that software component needs to be designed to development assurance level A. And this is really a development assurance level, not a failure probability, because it's hard to establish quantitative failure probabilities for software components. Alright, we talked about this before, I just added here again. So if you look for aircraft specifically, and this comes directly from Advisory Circular 23-1309C, in that case they have this severity level versus effect on airplane occupants and flight crews. So this kind of tells you if a system fails, where to categorize it. If a system failure could lead to complete hull loss, you have to say, well, that system must be designed to a catastrophic, must be classified as a catastrophic failure condition. So you must make sure that in your design that the failure probability is going to be highly unlikely, extremely improbable. So you see, in this table you kind of have it qualitatively assessed, what the effect should be. So for example, for minor, sure, the functional capabilities are slightly reduced, the safety margins are addressed, but you're not going to lose the aircraft. If you look at effects, minor for the occupants, they got to have some physical discomfort, major physical distress, maybe possibly injury. There may be some serious injury or even fatal injury to an occupant, and on catastrophic means you're going to lose multiple lives. So you see there is an increase in severity here. So based on, when you look at a system and you look at what it means for the system to fail, what it may lead to, what kind of consequences it may have, you can use this table then to establish the failure classification for this particular system. Yeah? So the determination of criticality for an aircraft system could be to be no effect, minor, major, severe major, or catastrophic. And the determination is really either done by, and it's among others, because these are just a couple of the examples, maybe established in certain advisory circulars or related documents, certain standards maybe, or TSO documents. It may be established by flight test personnel, even researchers, or it may be established by the Federal Aviation Administration. Now, and one thing it's always important to realize that if you have a particular concept, is what is the concept's intended function? Because remember, failure really means that it can no longer perform its intended function. Then you can easily see what the consequences are. Example I show you here, this is kind of an old synthetic vision display that kind of shows the pilot some basic information regarding the airspeed, altitude, and its orientation. You see it's rolled here, pitched down a little bit. And what you see on this, what makes it a synthetic vision display is the fact that it also shows a depiction of the outside world. So the problem is that you have to realize, okay, what is the, there we go. So what is the display's intended function really? If that terrain that's being depicted on this synthetic vision display shall be used by the pilot to make sure he stays clear of the mountains, then it's very important that that information that's being used by the display to show that mountain is very accurate. Because if he makes a decision based on that data, that actually, so for example, a terrain database that's being used to kind of generate that imagery, if there's a mistake in that, it could potentially lead for you to crash into terrain, and it could lead to fatalities. Yeah. So basically what you need to do is you need to say, well, this needs to be generated. It's a computer-generated depiction of the terrain. This is probably based on some terrain database. This means if you make an error in the terrain database, you may also make an error in the picture. Maybe offset maybe by a couple of feet. That's not good. If you use this display to make sure that you stay clear of the terrain, then you have to make sure that the information it provides is good enough. So this could potentially lead to a catastrophic or at least severe major failure. Now, if you look at 1309, 25309, also 23309, it really just kind of specified that you need to perform this determination of criticality for every system, and what you need to do this by means of quantitative and qualitative analyses of all these aircraft failure conditions. So the determination of criticality, you need to perform analyses for that. And that's what we're going to focus on in here. We're going to focus on what kind of analyses do exist so we can comply with 25309 that really establishes the safety for a particular aircraft or aircraft system. So you need to evaluate the safety and reliability of the systems, like we said, and what you need to do is you need to determine how these aircraft and systems will satisfy the safety objective. Now, if you establish for a particular system that you determine the criticality to be catastrophic, then you have to make sure how we're going to make sure that that system really meets that criticality level. In other words, how are we going to guarantee that the probability that a failure occurs is going to be smaller than 10 to the minus 9, for example, if you followed earlier table. There's a variety of different analysis methods that are, so if you look at these analysis methods, a variety of different ones that we're going to talk about right now. The list is here. We're going to talk a lot more detail about these in the next remainder of this module.